Hi friends, welcome to Unacademy, India's largest learning and teaching platform. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021 can subscribe the plus courses. Now when you join the plus courses, what are the benefits you are going to get? Students, first of all, both class 11 and class 12 topics will be done in detail. You will be given all the necessary tips, tricks to share the questions as quickly as possible. You are also given daily practice papers. You are given quizzes and you are given full-length mock tests with analysis. Single subscription student, unlimited access. You can join any one of the batches. There are different plans are available. 12 months plan we have, that is at the rate of 12,375. We have a 6-month plan at the rate of 10,125. Any of the batch, whenever you join, whichever batch you feel appropriate, you can join those batches, but make use of the code Bhavani Live. This code will give you the discount, maximum discount. So kindly make use of the code Bhavani Live and then join these batches. We have a comprehensive batch. We have a Kannada batch. So in case if you are comfortable with Kannada, you can join this batch. We also have a champions batch, and this is with different combinations like PCM, PCMB, PCB. So you can enroll your name for any one of these batches. And also students, you can also go for free practice tests for Karnataka CET exam. And the students see to it that you write as many as tests, so you enroll your name for the tests, and see to it that before the exam, before the test, you are trying to attempt as many as questions possible. In case if you haven't watched my previous YouTube session, kindly watch them. Whenever you like, kindly press the like button and do not forget to like, share and subscribe the videos. And also do not forget to subscribe the YouTube channel. So students, from the few sessions I have been conducting the CET test on solid state. So let us have few more questions which have been earlier appeared in the question paper. So let us go one by one. Let us deal with those questions. So you can see students, you have question number 1 on your screen. Now question number 1, the total number of lattice arrangements in different crystal system is. The total number of lattice arrangements in crystal system is. Option A 7, option B 3, option 8 C is 8 and option D is 14. Now how many crystal system, how many lattice arrangement we have for different crystal system? In case if you have the answer, you can actually note down the answer. You can write it in the comment box. So what will be the right answer? Okay, I can see all right, very good Srinivas. Immediately I have given the answer as 14. Now you can see here students, there are totally 7 crystal system. You have cubic system, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. So each system has a different arrangement. Now if I count 1, 2, 3, this is for cubic. For tetragonal 4, 5, this is for orthorhombic 6, 7, 8, 9. For hexagonal 10, 11 and monoclinic 12 you have, and this is 13, and for the triclinic you have 14. So altogether there are 14 lattice arrangement for 7 crystal systems. So the answer is, students, option D. Okay. We'll go to question number 2. When zinc converts to its solid state at its melting point, it has HCP structure. Then find out the nearest number of atoms. Option A is 6, option B is 8, option C is 12, and option D is 4. So zinc gets converted into a solid state where it acquires HCP lattice, hexagonal close packing, HCP lattice. Therefore, what is the coordination number? See, when it is asked the number of nearest number of atom, it's a coordination number. So students, what will be your answer? Is it 6, is it 8, is it 12 or 4? Whether it is HCP or whether it is CCP or FCC, the coordination number remains the same. The number of nearest neighboring atom remains the same, and that is 12. So 12 will be the answer. If the coordination number of a simple cube is asked, then it is 6. If it is about BCC asked, then it is 8. Whereas for HCP, CCP or FCC, the coordination number is 12 each. So answer is option C. 12 will be the right answer. I hope you know about it, all these things. Like for example, if you take a simple cube, and if you are looking at this particle, how many neighboring particle it touches? It will touch this particle 1, it will touch this one 2, it will touch this one 3, on this side it will touch 4, on this side it is 5, and here it is 6. That means the number of nearest neighboring particle is 1, 2, 3, 4, 5, 6. So for a primitive or a simple cube, it is 6. If you take BCC, student, now body centered cubic lattice, if you take the unit cell now here, consider a particle here inside the cube. With that we can count the coordination number. Now if you can see here, students, the particle here, we are finding out the number of nearest neighboring atom for this atom, one which is inside the cube. This will touch with this one, 1. It will touch with this 2, 3, 4, 5, 6, 7, 8. That means in BCC, the coordination number is 8. HCP, CCP, FCC, the number of nearest neighboring particle is 12. So answer is option C, 12. Okay. Go to the next question. The radii of Na plus and Cl minus ions are 95 picometer and 181 picometer respectively. The edge length of NaCl unit cell is, students, the radius of sodium Na plus and Cl minus is given. The edge length is asked in the problem. So how do we solve it? Suppose if you are looking at the structure of NaCl. Now students, if this is the edge, let me assume this as an edge. Now in this you will have, okay, this if I take it as Na plus, okay, 1 second students, let me, okay. So if this is the edge, we will take this as Cl minus, you will have Na plus, and then you will have Cl minus. So one edge when you take, you will have, this is Cl minus, this is Na plus, and this is Cl minus. Now the radius of Na plus and Cl minus is given. The radius of Na plus and Cl minus. So you have to find out this length, the edge length. So this edge length is 2 of radius, isn't it? You see, radius of 2 into radius of Na plus, this and this, and plus the radius of Cl minus, right? That means 2 into radius of Na plus is 95 and that of Cl minus is 181. So this will be 6 and 17 and you have 2, right? 2 into 276. So 255, isn't it? So what is the answer you're going to get? 552 picometer. 552 picometer. If you do not want to go with this formula, straight away you solve. See this radius, how much? 181 plus 95 plus 95 plus 181. That means 2 into 181 and 2 into 95. That will be 552 picometer. Answer is option D. I hope it is clear, students. Okay, what is the doubt? Okay, not understood, Srinivas, you have not understood. Okay, just see here. When we say sodium chloride crystal lattice, see, let me show sodium chloride. I have not shown the full diagram, isn't it? Now this is, you have like this, and you have like this, and you have like this, you have here, you have here, and you have here, and also you have like this, and this way, and this way, and you have this way. Okay, you have, I think, this way. Now this is actually Cl minus, this will be Na plus, this will be Cl minus. They will be touching each other. They will be touching each other. So I need not show all this. I want edge length, one side. So one side means you see the radius, 2 Cl minus, 2 radius, 2 of Cl minus, and you see 1 Na plus here radius, 1 Na plus, 2 of Na plus. So you add them, you get the answer as 552 picometer. Okay, we'll go to the next one. Very simple question, student. A compound is formed by elements A and B. This crystallizes in a cubic structure where A atoms are at the corners of the cube, B atoms are at the body center. The simplest formula of the compound is. Now students, directly you can find out, you need not even solve it. But for those who are listening for the first time, see, the theory, the concept is only so much. It is said that A is occupying the corner of a cube, and whenever a particle is at the corner, it is shared by 8 unit cells. If you remember, I have already solved such a problem. I mean the similar concept. Whenever particle is at the corner, it is shared by 8 unit cell. That means each unit cell will get a share of 1 by 8. So 1 by 8 of 8 A particles. And also we have, students, one particle B is at the body center. B is inside the cube. It is not shared by any other unit cell. That means this B particle belongs to this one. That means you have one B particle. So you have one A particle, one B particle. That means the formula will be option C, and that is AB. Okay, so simple question. Now go to the next one. An ionic compound is expected to have a tetrahedral structure if R plus divided by R minus ratio, that is radius ratio, lies in the range of. Now when do you learn, whenever a question is asked about a radius ratio, I have been telling you, you should remember the table. And it becomes very easy to remember the table, student. The question is tetrahedral structure means what is the radius ratio range? I think I have shown this table to you and I have asked you to remember less than 0.155. It's a linear structure. Coordination number is 2. 155 to 225. That means it is triangular. Coordination number is 3. 225 to 414. Then it is tetrahedral. So it is 0.225 to 0.414. That means our answer should be option D. Correct? Kindly see the table once again carefully. So 0.225 to 0.414, that means it is tetrahedral. 0.414 to 0.732, it is octahedral and the coordination number is 6. If it is 0.732 to 1, it is cubic. And like in the previous case I told you, hexagonal, HCP, CCP, all of these will have coordination number 12. So remember this table, it will be very much helpful in predicting the coordination number, that is the number of nearest neighboring particle. It is also helpful in predicting the geometry of the solid crystals. Okay. So once you know this table, if you have a look at this table 2 to 3 times, this range is very easy. Okay, so go to the next one. Edge length of a cube is 400 picometer. Its body diagonal would be. Edge length of a cube is 400 picometer. Its body diagonal would be. Option A is 566 picometer. Option B is 600 picometer. Option C is 300 picometer. And option D is 693 picometer. Now a body diagonal of a cube is known to us, isn't it? So what is a body diagonal? Body diagonal is equal to root 3, isn't it? Root 3 into A. Root 3 value is 1.73. Root 4 is 2. Root 3 will be 1.73. Edge length is given as 400 picometer. Therefore, 1.73 into 400. So it should be, if it is 2, it will be 800, isn't it? It is lesser than 800. So maybe the answer will be 693. Otherwise, you multiply and see. So answer will be option D, isn't it? Multiply and see. Karthik, I think, what is the name written? Yeah. See, multiply the root 3 into A. Okay. So you will have 3 4s are 12 and 3s 4. So if you want to calculate 12 and this is 28, 29, 2, 4 1s are. So it is somewhere around 692. That means 693 is the answer, picometer. Okay. Okay, go to the next one. A crystalline solid XY3 has CCP arrangement for its element Y? X occupies. Option A, 66% of tetrahedral void. Option B is 33% of tetrahedral void. Option C is 66% of octahedral void. And option D is 33% of octahedral void. A crystalline solid XY3 has CCP arrangement. CCP arrangement for its element Y. X occupies how much? What is the percentage of the void? Whether it is a tetrahedral void or is it a octahedral void? So students, when such a question is asked, how do we solve now? Now look at the question carefully. You will see that this CCP lattice is formed by element Y. Very clear, it is formed by element Y. That means atoms of number of atoms or number of Y atoms. Number of Y atom will be equal to, see, first of all, since the arrangement is CCP, what is the atoms in one unit cell of CCP? One unit cell of CCP. How many atoms you have, students? In one unit cell of CCP, how many atoms you have? 4, isn't it? For HCP, CCP, FCC, it is 4. So number of atom is 4. If the number of atom is 4, it is said in the problem that Y is the atom which is forming the lattice. That means number of Y atom also should be equal to 4, isn't it? Number of Y atom is equal to 4. Now the formula is given as XY3. XY3. Now if you have to get this formula, just see. Let us divide this entire formula by 3. Okay. Then you will get x1 by 3 and you will have y. We will multiply this, by 4. Then you will get x4 by 3 and you will get y4. We want number of y atoms as 4. So we have converted into that form. We got now number of y atoms as 4. It is very clear, if the number of y atoms are 4, the number of x atoms are how much? 4 by 3. That means number of x atoms equal to 4 by 3. So that will be 1 point, how much it will be? 33. 1.33. Now students, see carefully. This is a CCP arrangement. So the void will be octahedral void. So you have to mention the number of octahedral voids. If the number of atoms in the CCP is 4, number of octahedral void is also equal to 4. Right? If it is number of tetrahedral void, then it is equal to 8. Okay. So number of octahedral void is equal to 4. So you want the percentage of octahedral voids filled. When there are 4 atoms, when there are 4 voids, 4 by 3. Or you can write 1.33 also, student, if you want. If you want, you can write it as 1.33. So in 100 it is how much? You are just finding out the percentage. So this will be how much? this will be almost 33%. Okay, so the answer will be 33% of octahedral word. Now students, in case in the exam if you get a confusion now whether it is a tetrahedral word, you just see, you can solve the same problem, but number of tetrahedral void means this 4 will be equal to how much? 8, because number of atoms are 4, so number of octahedral void is equal to 4. Double will be the number of tetrahedral void, so this will be 8. That means the percentage you will be getting 16%. Okay, so the answer is only option D, and that is 33% of octahedral void. Option D is the answer. Now read the next question, student, and tell me what will be the right answer. Iron exhibits BCC structure. Iron exhibits BCC structure at room temperature, but above 900 degrees Celsius it transformed to a free structure. Okay, the ratio of density of iron at room temperature, this is FCC, student, FCC. From BCC it changes to FCC. The ratio of density of iron at room temperature to that of at 900 degrees Celsius is, assuming molar mass and atomic radii of iron remains constant with temperature. Now what is asked in the problem? Kindly have a proper look at the question. You have to find out the ratio. Ratio of what? Ratio of density. See, you have to find out the ratio of density of iron at room temperature divided by density of iron at 900 degrees Celsius. That's all. That is a question. Now when I say density of iron at room temperature, now what will be the formula, student? The formula will be, you know, Z into M divided by A cubed into Ne. Agree? So this one. This is for BCC. Room temperature, it exists as BCC. So if you want, you write BCC. And similarly, Z into M divided by A cube into Ne. Now this we have written for FCC. Correct, students? Now look here. Molar mass and atomic radii is almost same. Correct? So molar mass is same and the atomic radius is almost, remaining same, isn't it? So M is same. So what you can do is, you can write the formula now as you can see, for BCC, Z is equal to 2. Correct? Z is equal to 2. What is the A value for BCC, student? A value for BCC will be how much? It will be 4R by root 3. You have studied. Z is equal to 2 and the A is equal to 4R by root 3. And for FCC, Z is equal to 4 and A is equal to 2 root 2R. Correct? A is equal to 2 root 2R. So we will write 2, Z is equal to 2 divided by A cube. A cube means 4R divided by root 3. So 4R into root 3 cube. So instead of showing it together, students, let me show it outside. Okay, we will make a change. We will write root 3 by 4r cube. Correct? Divide by, students. Z for FCC is 4. Okay, it is 4. And it is 2 root 2r. R I am not mentioning because R will be getting cancelled. Okay, so 2 root 2. This is 4 divided by 2 root 2 cube. Correct? So if you are, cancelling, you will get R is getting cancelled here. So we are not going to write it. So 2 by 4 we will write as it is. You can simplify. Root 3 cube. So root 3 cube will be 3 into root 3. And similarly, if you can see here, this will be how much you are going to get? 2 root 2. Right? So this 2 will get cancelled. So you are going to get 3 root 3 divided by 4 into root 2. So the answer will come as 3 root 3 divided by 4 into root 2. See how you have solved. Just to have a look at the solution part. Method is very important. Solution you can do once you know how to solve it. Therefore you will get the answer as option C. Option C will be the right answer. So students, thank you for attending the class. We will see next class on 9th exactly at 2 o'clock, where we are going to solve some more problems from solid state. Till then, bye bye students. But then if you have liked the class, do not forget to like, share and subscribe the classes. Do not forget to share these videos among your friends. So bye students and take care.